Okay, so let's do part 2 of 8.4, multiplying and dividing rational expressions. So to warm up, here's that problem from yesterday at the end of the video. We want to multiply these expressions. So remember, we want to check that we can factor anything. Okay, and then 2, we want to start canceling top and bottom. So if we can factor, let's factor. So starting in the first fraction, I see 3x minus 12. This is two terms. Do they have anything in common? If they do, let's factor it out. And they do. The number 3 is in common. So we take out a 3, and then we're just left with an x. And when we take out, we're dividing, right? So 12 divided by 3 would be a 4. Underneath x plus 5, they don't have anything in common. So that's its own expression, right? And then we have x plus 6, same thing. Can't do anything there. But 2x minus 8, they do have a number in common, and that number would be 2. So we'd get x minus 4. The reason I put everything in parentheses is because I don't just want to cancel out an x and an x, right? Those aren't common factors because they're trapped with an expression. This is x plus 5 as one entity. Same thing, x plus 6. So what can I cancel is the entire x minus 4 entity, but I can't cancel anything else. Can I simplify the 3 over 2? Do they have anything in common? And no, they don't. So up top, I just have a 3 and an x plus 6. And then let's make this all one fraction, right? Because it's multiplication. And then down below, I have a 2 and an x plus 5. Again, we cannot just cancel out our x's. That's one entity. So we box in our answer after we're done canceling. And we're done. There may be sometimes, though, when you are multiplying that it doesn't look like two fractions. So the previous one was clearly two fractions, but this one is one fraction times it by a polynomial. But remember, keep in mind that this is actually a fraction if we write it over 1. So now we're back to our steps where we factor and then we cancel top and bottom. So x minus 4 can't be factored. X cubed plus 8, they don't have anything in common, and this is kind of a tricky one, but it is the sum of cubes. X cubed and 8 is really represented by 2 cubed. So I'll just show you the sum of 2 cubes, what that looks like. If you don't remember, it's going to be x plus 2, right? So the first thing being cubed and the second thing being cubed. And then an x squared minus our a times our b. And in the back, it'd be our b number, or our 2 squared, so 4. And in the middle, if we multiplied our a, which is x, times our b, which was 2, it'd be 2x. So this, if we FOILed it all out, we would get x cubed plus 8. Our other fraction, x squared minus 2x plus 4. So we may think, let's look for two numbers that multiply the 4 and add up to -2, and maybe we can factor that. However, one thing that I notice is that if I didn't factor it, would it match something in the denominator? And it actually would. So we already have a match that we are able to cancel, and I don't need to go that step further and factor it, okay? So yes, we can cancel out 3 terms as long as everything matches, right? All the signs were matching. It was minus 2x and plus 4, minus 2x and plus 4. So those are gone. Anything else up top that I can cancel with down below? I have an x minus 4. I can't cancel that, so he's got to stay. And down below I have a x plus 2 times a 1. Well, anything times 1 is itself. So my final answer is x minus 4 over x plus 2. Now division. Division works almost identical to multiplication, but we have to do one important thing. In order to divide, we're going to have to reciprocate the second fraction in order to multiply. So here's what that looks like. I have a division of two fractions. You may have heard keep, change, flip. That's what this is. I don't like keep, change, flip. So I like to say multiply by the reciprocal. All right, so I'm going to be able to change this into a multiplication problem if I take my first fraction and I flip my second fraction. So I changed the division into multiplication, and I'm going to flip this guy upside down so that x squared minus 100 is in the top, and x squared plus 3x minus 70 is in the bottom. And now I'm right back to the problem before, where I need to first factor it and then cancel things. So let's go ahead and factor this. 3 terms, those are the numbers that multiply to negative 21 but add up to negative 4. Well, 21's factors are 7 and 3, so let's try 7 and 3. We just need to decide who's negative and who's positive. So negative 7 plus 3 would put us at negative 4. In the denominator, those two terms are something that's in common, so let's factor out a 5. When we take a 5 and divide it by 5x to get x, and 15 divided by 3 is 3. Let's factor our other fraction. We have a difference of 2 squares. This is x squared and this is 10 squared. So we want x plus 10 and x minus 10. Down below, are there numbers that multiply to negative 70 and add up to 3? Well, numbers that multiply to 70 are 10 and 7. And we need to decide which one's going to be negative and which one's going to be positive. So we want a positive 10 and a negative 7 to put us at positive 3. Okay, so we factored it. Now we're going to have to cancel. So let's work on finding something up top that's also down below. So x minus 7 and x minus 7, x plus 10 and x plus 10, x plus 3 and x plus 3, leaving me up top with just the x minus 10 and down below the 5. Here's what I do not want you to do. I do not want you to simplify 10 and 5 to 2 and 1. Why can we not do that? Because this is one expression. X minus 10 is in parentheses. So if you like to write it in parentheses to remind yourself that's held together, please do so. And we box in our answer after we've done canceling everything. Okay, so that's division. You're going to keep, change, flip, or in other words, multiply by the reciprocal. Okay, the same thing goes here. It's two fractions. Remember, this one's in disguise. It's over 1. So you're going to keep the first fraction, change division to multiplication, and you're going to flip this upside down. So now that the 1 is at the top. For the sake of time, I'm not going to go over it. After you keep, change, flip, we would factor, and then we would cancel. So division is a lot like multiplication. You just have to keep, change, and flip. Questions? Come see me during office hours.